Good morning, ladies. How you've been? Today we're going to start a new lesson that talks about the absolute value functions and graphs. Okay, just as the absolute value of x is its distance from 0, gives the distance from the line y equals 0 for each value of f of x. Okay, the simplest example of an absolute value function is f of x equals the absolute value of x. Or let's say that this is the parent function, okay? The graph of the absolute value of a linear function in two variables is V-shaped and symmetric about a vertical line called the axis of symmetry. So the axis of symmetry, somehow we're going to have it at the y-axis, axis of symmetry. Such a graph has either a single minimum point or a single maximum point called the vertex. So this is the vertex. The original or the apparent function for the absolute value function is f of x equals radical x, absolute value of x is when the vertex is 0, 0, 0x and 0y. Okay, this is and here we're having like the minimum point called the vertex. Some graphs you're gonna have it as the maximum point and it's gonna be like flipped. Now let's have it this way. Okay, so now here the absolute value function, here's the key concept. For example, if I have the x as -3 and the absolute value of x or f of x equals the opposite side of it, a positive value of it. Okay, so we're going to graph it this way. We're having here negative values and we're having here positive values, but the original function here or the original graph says that all the y values here is positive, or the y values here are positive. Okay, so here the function, when we have an absolute value of x equals x when x is greater than 0, we also have it negative x when x is less than 0. So it may be inside the absolute value positive or negative x. But when we find it after all, the absolute value will give me a positive answer. Okay, so all of us know this information. Now here we're going to start with the first problem, graphing an absolute value function. What is the graph of the absolute value function y equals absolute value x minus 4? How is this graph different from the parent function that we have? Okay, let's remember that we have the parent function here. Let me put it with this color. The parent function, we have it here, is when the vertex is 0, 0, right? Let's have it this way, and we have here, and we have it here as 0, 0, right? So this is the parent function here. Now, if we have y equals absolute value of x minus 4, it means we have translated 4 units down because it's negative. So we translated 4 units. Let's see here. It's going to be as 1, 2, 3, 4. Oh, the last one here is wrong. Okay, like as 1, 2, 3, and 4. So instead of the vertex going to be 0, 0, originally it's 0, 0, it became 0, negative 4. So we had a translation 4 units downward. Either you're going to write this like you're going to have different values here from -3 up to 3. We're going to draw the original one. Then we're going to subtract by 4 to find the answers here. Or each point here, you're going to translate it 4 units downward. So since the vertex is at 0, negative 4, you translated the graph, this function, you translated the graph of this function down 4 units. Okay, so this is how it's different from the original function. Let's go for the second example we have. Graphing an absolute value function here again. What is the graph of y equals absolute value of x plus 2? How is this graph different from the parent function? Okay, so obviously here we're having, this is the parent function, but we're adding 2 here. So it means we had a transformation here. This transformation is plus 2, which is moving the function or the graph, translating the graph 2 units upward. Okay, so originally, let's draw it again here. Originally the graph is going to be this way. It's going to be somehow this way and this way. Okay, so this is the original graph we have. Here we added 2, right, plus 2. So So it means we're going to move it 2 units upward. 1, 2 actually here, because it's moving 2 by 2, so it's going to be like as 1 and 2. So it's going to be 4 instead of, oh no, I mean here's 0 and here's 2, so it's going to be as 0, 2, the vertex here that we have 0, 2. So since the graph has a vertex at 0, 2, it is the parent function translated up 2 units. So in this example, in the previous example, you only have to say what did it change, what this graph or this function have different from the parent function. You're going to say how much it translated or reflected or stretched or like compressed, like the 4 types of the transformation. Okay? So let's see what's the next idea here. Okay. Here we just have like a quick summary about the parent function that we have here of the absolute value, and we have the vertical translation, horizontal translation, vertical stretching, compression, and reflection. So it's just a summary for you to remember these 4 transformations. Okay, let's continue with problem 2. Here we're combining translation. We have more than one translation. Okay, here they're asking what is the graph of the function y equals x plus 2 inside the absolute value, then plus 3. Okay, so girls, we have to think like originally it's going to be as, where's the mouse here? It's going to be as, here's, let's say that this is the graph, and originally the graph of the what's wrong here again? Okay, so the graph originally, the parent graph is going to be this way. So the vertex is going to be here 0, 0. Now they're asking here what is the function when x plus 2 inside the absolute value, then plus 3. So originally, the first thing we have to know that when we have inside the brackets or inside the absolute value addition or subtraction, it means the translation here is going to be horizontal. Now if we add it 2, it means we're going to move how many units to the left or to the right? We're going to move 2 units to the left. So it's going to be as here 1, 2. So it's going to be from here as negative 2 at this point, I mean negative 2. So first of all, we're going to have negative 2, the vertex, I mean. Then we're going to see moving 3 units upwards, moving 3 units, 1, 2, 3. So we're going to reach at point 3. So it's going to be as 3. Now we're having the vertex supposed to be at negative 2, 3. So we're going to search in A, B, C, D when the vertex is negative 2, 3. So here the vertex is negative 2, negative 3, so it's wrong. So here it's going to be as not negative 2. This is wrong. Let's see here B. It's going to be 2, 3, which is also wrong. Let's look at C. It's going to be 2, negative 3, also wrong. Here it's going to be negative 2, 3, which is correct. So my answer is going to be D. Now here, let's see what did they write? Compare y this to each from as this. Okay, the parent function is translated 2 units to the left, as we said. Then the parent function is translated 3 units up. So the parent function is translated 2 units up and 2 units left and 3 units up. The vertex will be negative 2, 3, as we said. Then we're going to check the correct choice will be D, as we answered. Okay, let's see the second example we have. What is the graph of the function y equals negative 2 plus 1? Okay, so again, let's have it here this way as the original one is going to be as this way. This is the original one. Then they asked for, here they said negative 2 inside, so a horizontal translation. Negative 2, it means 2 units to the right. So we're moving 1, 2. We're going to reach here. We're going to reach here when x equals 2. Then We moved 1 unit upward, so we're going to move here, we reach up to 1. So it's going to be as 2 1. The vertex is going to be as 2 1. This is the vertex, so we're going to choose 2 1. Here's the vertex, and then we're going to draw it. Okay, so the parent function is translated 2 units up, right 2 units and 1 unit upward. Okay, so that's how you find it easily. First of all, you're going to find the vertex, then you're just going to plot it here. Okay, let's go for the third problem we have here, which is vertical stretch and compression. So in these two previous examples, we had translations like moving upward, or like vertical movement, or a horizontal movement. Okay, now for problem number 3 is the vertical stretch and compression. We're stretching it or or using compression. So what is the graph of y1 over 2x? So originally, let me just draw it over here because I just don't want to draw it over and over again. It's supposed to be this way, as the V shape this way. Okay, so the graph is a vertical compression of the graph, so by a factor of half. Here it's compression because the a here, or the number that's multiplied by f of x, is between 0 and 1, so it's going to be compression. So we're just going to write it like we're going to just make a table, assume some points, and find the answer for them. Graph the right branch, use the symmetric. So the right branch is always symmetric to the left branch. They're symmetric to each other. Starting at 0 0, graph 1 over 2x. Make a table, and then you're going to assume numbers for x, then you're just going to find the answer for y and plotting them. So here for stretching or compression here, originally if there's no addition or subtraction here, the vertex is going to be the same. You just use the table to find the answer here of these points. Okay, let's go for the second example we have here. Okay, what is the graph of the function y equals 2x? So again, it's going to be the same here. They multiplied the original function or the parent function by 2, so it means we're going to have a vertical stretch because it's greater than 1. You're going to do the same thing, make a table and assume numbers to find the answer here. Okay, so originally the graph is going to be this way, and after, supposedly after it's going to be stretched this way. Okay, let's see. Oh, that's it for today, girls. So we're done with the translation and vertical stretch and compression. Now let's have a quick summary here. That the absolute value is we're going to have positive values of x and negative values of y, and they're both symmetric to each other. That's it for today, girls, and have a nice day.